Paper 3 continued. Factorise the expression 6x squared minus 11x minus 10. As we did earlier, as soon as we see anything with an x squared and x and a number on the end, we need to be looking at multiplying and times it. As there's a number in front of the x squared, we have to multiply this time to make minus 60, but we're still adding just to make minus 11. Two numbers which do that are 4 and 15. Again, to make one of them this answer negative, one of these will have to be minus, and if we want to end up as negative as that, we're going to have to start with the minus 15. We can't go straight to the brackets because of this 6x squared. What we have to do is we have to split the minus 11 into these two components parts, which gives us plus 4x and minus 15x, sorry, and the minus 10 on the end. Then we look at factorising the first part and factorising the second part. We factorise this part and we find 2x is common and we get 3x plus 2 in the bracket. Keep the sign as it is. In here, all that is common is a 5, and again we would need 3x, and we'll need plus 2 here because plus 2 times minus 5 makes the minus 10 we want. If you have written the 4x and 15x in the other way round, you will still end up with the same final answer. So our two answers are the bracket we've already got, which is repeated, and then the two terms from outside the bracket create the other bracket. They want us then to solve it equal to 0. So we say either 3x plus 2 equals 0 or 2x minus 5 equals 0. In this case, we take the plus 2 over, which gives us 3x equals minus 2, and then we divide to get minus 2 over 3, and we follow the same pattern over here. So 2x will equal 5 by taking that over, so then x will be 5 over 2. Again, you can cancel that down to be 2.5, but if you're not 100% confident in that, leave it as 5 over 2. Part B. Need to recognise here that we have a difference of two squares question. To notice a difference of two squares, we have to have a minus in the middle, and all parts of the expression will be squares. In our answer then, we know one bracket will be plus and one bracket will be minus. We square root each part separately and just fill them in the bracket. The square root of 4 is 2. Square root of y squared is y, and then the square root of 81 is 9. And that is the end of that answer. Question 12, probability tree diagram. At lunchtime, the probability that Molly has a sandwich is 0.7. That has been filled in, so the probability she doesn't has to be 0.3. Whether or not Molly has a sandwich, the probability that she has an ice cream is 0.2. So Molly has an ice cream is 0.2, therefore Molly doesn't is 0.8. The first thing about sandwiches was irrelevant when it comes to the ice cream, so this again is 0.2 and 0.8. Calculate the probability that Molly has a sandwich for lunch and has an ice cream mid-afternoon. So she has a sandwich and she has an ice cream. As we go along branches, we multiply. So we have 0.7 times by 0.2, which is 0.14. Question number 14. The graph shows x cubed minus 3x squared minus 13x plus 4 plus 15 between x equals minus 4 and x equals 6. Use the graph to solve x cubed minus 3x squared minus 13x plus 15 equals 0. So if this graph has to equal 0, that means that we draw a line across at y equals 0 and we read off the values. So it is minus 3, 1 and 5. So there are three solutions and they are minus 3, 1 and 5. Using the graph, estimate the gradient of the curve when x equals 4. When x equals 4, that is here, so that is the point there we are trying to work out the gradient of. In order to do that, I'm going to draw a tangent and I'm going to hope to touch that point and no other part of the graph. You need to get that as close as you can, and I would suggest you draw the line as far as you possibly can. Then in order to find the gradient, we are going to turn this into a triangle in some way. It doesn't matter how small or big you turn this line into a triangle because the gradient will be the same at all points. I am going to go for that here, and the examiners are quite lenient on this question because, as you can imagine, everyone's tangents are slightly different. I need to look at the increase in y, so I'm going up 10, 20, 30, 1, 2, 3, 4, 5. So the increase in y is 35. The increase in x is slightly different. Going across in x, each 10 squares is worth 2, so therefore each little square is only worth 0.1. 0.05 even. So I have, altogether I've got 10, 11, 12, 13, 14, 15, 16 squares. So that is worth, 10 squares would be worth 2. So it's going to be 2.05, 2.1, 2.4, 2.6 in total there. So then I am going to do 35 divided by 2.6. Now bear in mind this is a non-calculator paper. I am going to turn that into 350 divided by 26, and then I'm going to work out how many 26 is going to 350, and there's nothing wrong with using a method for division in order to do that and get your answer to a couple of decimal places. 26 doesn't go into 3. How many 26 is going to 35? 1, remainder 9. How many 26 is going to 90? 26, 52, 78, so that would be 3. Put a decimal point, a couple more zeros. So we had 78, so we've got 12 left over. How many 26 is going to 120? So 26, 52, 78, 104, 130, and we've got 1, 2, 3, 4 with 10 left over. How many go into 100? 1, 2, 3. And then I would leave it at that, and I would give a gradient of 13.43. Part C, by drawing an appropriate line on the graph, solve the equation x cubed minus that. Now we need to make this that they've given us exactly the same as the original equation of the graph. Now, to get from the equation we've got to the equation of the graph, we're going to have to add 10. If I have to add 10 on that side, then I must add 10 on this side. So that tells me that from my original, all of this now will be exactly the same as this, which means I'm left with y being equal to 10. So to solve that, then I am going to draw a line on my graph at y equals 10, and the points at where this graph hit the x-axis, so there is one there is one here, and there is another one here. Make sure you use a ruler to draw these lines. This one is at 5.1, this one is at 0.1, and this one is at minus 2.2. So I have minus 2.2, 0.1, and 5.1 as my solutions. Your answers might be slightly different because your interpretation of the graph is slightly different, but they need to be close to that. Use the trapezium rule with 4 strips to estimate the area of the region enclosed by the curve between x equals minus 3 and x equals 1. You need to know that the trapezium rule is a half y0 plus yn plus 2 lots of y1 plus y2 plus y3, and so on. Y0 is the value at this x equals minus 3, which if we look at the graph at x equals minus 3, the y value is 0. So this is 0 plus. Yn is at the final one, x equals 1. Again, that is a 0 there, plus 2 lots of everything in between. So at minus 2, we have the value 21. At minus 1, we have the value 24. At 0, we have the value 15. And then we are done. So we need to add these 3 numbers together, which gives us 45, 60. So we have a half of 2 lots of 60. 2 lots of 60 are 120 and halved. That gives us an answer of 60 for the gradient. Question 15. Express 0.652 as a fraction. So we're going to let a equal 0.652, and it's only the 52 repeating, so 52, 52, 52. I need to multiply this by 10, 100, 1,000, something in order to keep the repeat in line so we can subtract and cancel. If I multiply by 10, only the 6 will come across the decimal point, and then it will have 5, 2, 5, 2, and that won't line up. So I'm going to multiply by 100, and in this case 2 of these numbers will come across the decimal point. 65 will come across, and I will have 2, 5, 2, 5, 2, 5, 2, 5. So I see that all of these will now cancel. So I am left with 99a is equal to, and I need to be careful here because I haven't got rid of everything after the decimal point. So I have 65.2 minus 0.6, which gives me 64.6. So a is equal to 64.6 divided by 99. I cannot have fractions and decimals together, so I need to multiply by 10 to get 646 divided by 990. Part B. surds. Given that p equals root 5, q equals root 13, and r equals root 325, simplify p, q, r. So I have root 5 times root 13 times root 325. I can't simplify this any further or this because they're both prime numbers. However, root 325 can be simplified. So root 5 is going to stay as it is, root 13 is going to stay as it is. I need to find any number that goes into 325. If I can find a square number that does, it will make my answer quicker, but it won't make it any more right. So 25 will divide into 325, and it goes in 4, 8, 12, 13 times. Root 5 again I can do nothing with. This root 13 and root 13 here just multiply to give me the whole number 13, and I know that root 25 is the number 5. So I now have 13 times 5, which is 65, and the root 5 that I can do nothing with, which is the final answer.